So last week we did derivatives of tan. Before that we did derivatives of sine, cosine, all pretty not that difficult stuff. Today what we're gonna do is we're gonna flip the switch. Now you're gonna have to bear with me here. It's not terribly difficult, but we're gonna do the exact opposite thing that we've been doing for the last couple of months. So far we've done derivatives. What this is the slope. You have a function. Let me just draw some weird looking thing, something like that. The derivative is the slope of this function at a certain point. So that would be y prime of a. If this is y, that'll be the y prime, the slope at some point a. Now, instead of finding y prime at a, what you could find is you could just find y prime. And this is the general slope function for y. This one will give you the slope for any point given a point, basically. General slope form. So for example, x cubed, the derivative is 3x squared. This is the general slope form of x cubed. And if the question asks you, well, what's the slope at 1? Then you just plug 1 in there. You'll get that the slope of x cubed, which kind of looks like this. At 1, the slope of this tangent line is going to be 3, right? That's what we've done so far. And it's the same concept to any function. Doesn't matter if it's trig or exponential. The concept is the same. Derivative is just the slope. Now, the opposite of derivative, sometimes it's called the antiderivative. I'm not going to use this term, but this is also the name of this. Antiderivative. The term that I'm going to use is called the integral. So it's the exact opposite of a derivative. Let me give you a quick example. Let's say you have a function y equals to x. This is y equals x. What is the slope of this function at any point? What's the m? It's just 1, right? So the derivative of this is going to be 1. The slope at any point is going to be 1, right? Linear functions, the slope never changes. If it's minus 2x plus 3, the slope at any point will be minus 2x. That is the derivative. Now, what is the integral? Integral is the area under the curve. So let's turn this into a triangle. So we have something to work with. Integral is the area of this curve from point A to point B. Let's say this is point A. Let's say this is point B. Integral is the area. Now, sometimes they will give you these points. Sometimes A and B will be given. If A and B is given, then this is called a definite integral. You can calculate the exact area because you can turn it into triangles. Well, that doesn't sound right because what if it's a curve? Something like this. Now that one, let's say this is point A. Let's say this is point B. How do you turn that into a triangle? We don't turn that into triangles. What we do is we turn this into small strips. And these strips are infinitesimally small. I butchered that word, but basically it has almost no length. It has a certain length, but it's almost nothing. It has a length of dx is what we call it. So we turn this into many, not triangles, rectangles, okay? And the width of these, the height we can find from the curve. Like the height here would be whatever the y value is. The height here would be whatever the y value is. So if you think about this is a strip. The height, we know this. This is just the y value of the function. And then this strip is almost nothing. It's almost 0, but it's not 0. We call that dx. The length of this, the width of this is dx. And we find the area of this rectangle for all of these strips. Thankfully, we don't have to do it manually. That would be impossible. We're going to use some formulas to do it. But the main point here is that If they give you points A and B, then it's called a definite integral. If they don't give you any points, sometimes they don't care, which is basically if like saying you have a y function, find y prime. See, they're not asking you for the slope at any specific point. They just want the general slope function. It's kind of like that. If they don't give you any points, then this is called an indefinite integral. The answer will just be in terms of x in the general form. Whereas on the top one, when they give you points, the answer will be in terms of a solid number, just like the derivative, just like y prime of 3. The answer will be a real number. We're not going to do complex derivatives. We'll see, not yet, not in this next course. So that's the idea. Integral is the antiderivative, the opposite. We're finding the area under the curve. So let me show you a quick example. The easiest integrals are polynomials. Just like how the easiest derivatives were also polynomials. So let's look at x squared. What's the derivative of this?
2x.
2x. So y prime would be 2x. Now an integral question would look like this. They give you, they won't say it, but they will give y equals to this symbol right here. This is called the integral. Integral of the derivative function, 2x. And like we saw before with the strips, there's always going to be something attached here. The width of this strip is always going to be d of whatever the variable of interest. So here the variable of interest is x. So you have to attach a dx here. So that'll be the question. What is the integral of 2x? Now it's the exact opposite as the derivative. How did we find the derivative? We put this in the front, right? We subtracted a 1, yeah?
Mhm.
That's why you get an x1. Now what you do is that you're going to put this right back in there. So when you put that right back, we're basically working backwards. This way is derivative, this way is integral. And we know from right here, the integral of 2x is x squared, okay?
Yep.
If they give you points A and B, they will be written right here, A and B. Well, it's going to be usually real numbers, so they will maybe say 1 to 3 like this. So these 2 points, the lower bound is called A, the upper bound is called B. What you do with these 2 numbers is once you find the integral function, which is in this case x squared, you're going to open a straight line here, and you're going to put these 2 numbers. So you're going to put the lower bound here as 1, upper bound here as 3. And then what you do is that you're going to plug the upper bound into the function. So it's going to be 3 squared minus, it's always going to be minus. Whenever you have an upper or lower bound integrals, you're always going to join them by subtracting them. Next, you're going to put the 1 in there. So it'll be minus 1 squared. This is 9 minus 1, that's 8, okay? That'll be the final answer for this definite integral. Now, if they don't have the 1 and 3 attached, the final answer will be x squared, and this is a little bit weird, plus some constant c. Now, why is this? Because when you take the derivative of this, the constant disappears, you get a 0, right? So there could be some constant attached to the integral. We don't know what that is. That c is any real number. Can be 0, cannot be 0. But the main point is that the c always disappears whenever you take the derivative. So if you have an indefinite integral, this is where they don't give you a and b, you have to attach a plus c element to your integrated function, okay? Now, let me show you what this 8 actually means. And again, linear function, it's pretty easy to see what's going on. So our function is 2x, so it has a y-intercept of 0, and then it has a slope of 2. So it looks like this. This is 2x. our values of interest is 1 and 3. So 1, the y value is 2. 2, the y value is 4. At 3, the y value is 6. It should have been 6. 4, 5. What happened here? 2, 4, 5, 6. That point should have been right here. Anyways, just pretend that this line is a little bit on this side. This should be directly above this. The y value there is what? For 2x, what's the y value when the x value is 3? It's going to be 6, right? Yeah?
Yeah.
So from 1 to 3, check this out. From 1 to 3, what the integral gives us is the area from here to here. Now, how do we find the area of this? We can turn it into a triangle and we can turn it into a square on the bottom, okay? This square has units, the height is 2, the width is 2, so the area of the square is 4. This triangle has a base of 2, has a height of 4, right? Base times height divided by 2, and you will see that the area there is also 4. So what's the combined area? It is going to be 8, 4 plus 4. So that's what the integral gives you. It gives you the area under the curve. Now, for straight lines, it's simple. You don't even need to use calculus or integrals to find the area. But where this comes really handy is when you have a curve. Let's try this next. Let's say 3x squared plus 4. Let's say this is our y. The question is, no, let's make this our y. The area from, let's say, 0 to 3 of this function. And now this is a quadratic that has a y-intercept of 4 and kind of looks like this, right? Now what this question is asking you is from 0 to 3, let's say this is 3. And again, it doesn't have to be perfectly straight. These are just rough sketches. What is this area is the question. Now that you can never find by hand. Not precisely. It's never going to be 100% precise. Even if you draw it by scale on a graph paper, it's never going to be 100% precise. So that triangle square method fails when you have a curve. So you have to use the integral to find the area. All right. Now you're going to have to bear with me here. 3x squared, this is the derivative. You have an original function. When you took its derivative, you got 3x squared. What is the original function?
X cubed.
X cubed. What about for 4?
4x.
4x. So x cubed plus 4x is going to be your integrated function. So here you put 0, 3. Once you do the integral, the dx and the integral sign cancel each other out, okay? So this is what you get. From here, you just plug the 3 and the 0 here. And remember, the sign between the upper bound and the lower bound is going to be minus. So you plug 3 in there, it's going to be 3 cubed plus 4 times 3 minus, well, always remember to put a bracket after a minus sign. 0 cubed plus 4 times 0, which is 0. So it's going to be 27 plus 12, 39. So the area here, this blue part, is exactly 39 units. Now that would not have been possible to do with hand, not precisely anyways. So that's the power of the integral. Cool? That's it. That's the core concept of integrals. Okay, let's see if we can come up that this is the function. X cubed, right? What do you think the integral of this is? You have a cube. Start there. It's always going to be 1 power higher. Yeah, remember this. If you have a times b to the power of n, or let me just write that as x. If this is your y prime will be n times a times x to the power of n minus 1. You see that?
So it was 3x to the power 4.
3x to the power of 4 is perfect. There you go. That's the answer. Is this a definite or an indefinite integral?
Indefinite.
So you have to add a plus c. Final answer, done. This one looks weird, but as long as you can write it in the polynomial form, you're good to go. So again, before you do anything, just write it in this form. You can always move the t up there. So now think about it. You had some function. When you took the derivative, you got 6t minus 4. What should be the power of t here?
-3.
-3. Now, if you were to take the derivative of this, you would get -3 t to the -4. But here, instead of having a -3, you have a 6, right? So what do you need to multiply it by?
-2.
-2. So what's the final answer? T -2 t to the -3. See if that made sense.
It does.
Because you need a 6 there, right? And the only way to get a 6 is that you have to multiply it by -2. So think about it this way. It's not that difficult once you start seeing it in this form. This is the same. Oh, this one is not the same. Almost messed it up. So this one's a trick question. This one, I have to tell you how to do it. So you have this. Now that approach that we used previously does not work for this question. You have some function. When you take the derivative, you get x minus 1. Then you would think, well, it must have been an x to the power of 0. But remember, x to the power of 0 is a 1, right?
Mm.
So it was not x to the power of 0, because that by itself would have been a 1, and the derivative would have been a 0. But here, the derivative is x minus 1. So that polynomial rule fails here. When the power is -1, that rule we just saw, it fails. This is a very special case. This is when your x has a power of -1. When this happens, the polynomial rule where we just add +1 fails. So now how do we attack this one? Turns out, here's the general formula. If you have 1 over x, the integral of 1 over x is ln. Remember what ln is? What's ln? Ln is the inverse of what function? E power x, okay? Ln means the natural logarithm. Ln is equivalent to log of base e. Ln of x is equivalent to ln of a log of base e x. It's the inverse function of e power x. Cool? That's what ln is. So the integral of 1 over x is ln of x, which means the derivative of ln of x, if this is your y prime would be 1 over x. Cool? So here, look at this. This is just a constant. You can even treat this as a bracket. You can pull the constant out. So that too, you can write it like this. No difference. And we know the integral of x minus 1 is ln of x. So this becomes 2 times 1 over ln x. I'm going to write it in this form. The integral of x minus 1 is ln x. And there you go. That's the final answer. Cool?
Mhm.
And let's look at this example. Let's say you have x minus 2 plus x minus 1 integral like this. Now this one, you can use the polynomial rule. It must have been x to the power negative what? 1 or 3?
1.
1. Now, if it was this, then you would get negative x to the power -2. But here, there's no negative sign. So what did we must multiply this by? The derivative of this, as is negative x to the -2. But our function doesn't have that negative sign, right?
Mm-hmm.
So we must have multiplied it by -1. So that will be the integral. Cool?
Mm-hmm.
What's the integral of x to the -1? Which is equivalent to 1 over x, ln of x, okay?
Mm-hmm.
Plus ln of x plus c, because these are indefinite integrals. And that's the final answer. So this one, when you have x power -1, this is a special case. The integral is ln of x. This we can write it in polynomial form. So this you can say it's equivalent to x to the power of 1 over 2 dx. So now we're finding the integral. Instead of subtracting 1 from the exponent, we add a 1. So this will be x to the 3 over 2, right?
Mm-hmm.
But if you take the derivative of this as is, you would get 3 over 2x to the 1 over 2. But there's no 3 over 2 here. So what do we multiply this by to get rid of that 3 over 2? 2 over 3. Flip it. You just want it to be a 1 at the end, right? Here, let me show you this. If you do this, the derivative, let's say this is y prime would be 2 over 3 in the front as is, times 3 over 2 times x to the 1 over 2. These cancel each other out. It's a 1. So you get 1 over 2, like that. Okay?
Mm-hmm.
In fact, I'm going to give you a general form here. Maybe it'll be easier, especially in the beginning. If you have x to the power of n, something like this, the integral of that will be x to the power of n plus 1, okay?
Mm-hmm.
All over n plus 1. You need to divide it by that exponent. So here, if we compare this with x power 1 over 2, so you have x to the power of 1 over 2 dx. The integral will be x to the power of 3 over 2, okay? Divided by 3 over 2. And you have a divided by b over c. The 2 is going to come all the way to the top level. You'll have 2 over 3 times x 3 over 2 plus c. And that's going to be the integral. Because when you take the derivative of this, the 2 over 3 and the 3 over 2's, they're going to cancel each other out, and you're not going to get a coefficient in the front.
Mm-hmm.
So maybe you can use this. You always divide it by the new exponent. Here's another easy example. Let's say you have 6x squared. Again, sometimes you have to think about this because now you have a coefficient in the front. The integral of x squared is x cubed. What should we multiply this by to get a 2 there?
By 3.
So 3 is going to come down, right?
Mm-hmm.
So it should be 2. Because the 3 will come down. 2 times 3 is a 6, and that becomes an x squared. There you go. That's the answer. Cool?
Mm-hmm.
It's okay if you don't get it completely. You will get it. The exponent for polynomials always goes up by 1, and then you have to think about, well, what do I multiply it by to get this? Now notice there's a plus sign. We have not seen anything like this. What you can do with integrals is that a lot of the mathematical operations that we use for things like a bracket also applies to integrals. So what you can do is you can separate them. 5u4 du, like this, plus integral, another integral. Treat that as a bracket. Then you'll get 9u squared du. And because these are constants, you can pull them out of the integral. So you can even write it as 5 times u4 du plus 9 times u squared d. What's the integral of u to the 4?
It's u to the 5.
Divided by what? Because if you have this, you're going to get 5 in the front, right?
Mm-hmm.
So you need to get rid of that 5. See if that made sense. u5, the derivative is 5u4. But here, we don't have a 5, right?
Mm-hmm.
So the only way to get rid of that 5 is if you divide by it. So the integral of u power 4 is going to be u power 5 divided by 5. Because now if you look at it, you get 5u4 over 5, and this 5 cancels out, and you're simply left with u4. Cool?
Mm-hmm.
What's the integral of u squared? It's going to be u cubed, but now think about what do you need to multiply it or divide it by? U cubed would have given you 3u squared. Notice how there's no 3 here. So what's the way to get rid of this 3?
You divide by 3.
You divide by 3 like that. And then there's a plus c component. So the final answer here will be u power 5 plus 3u power 3 plus c. That's going to be the final answer. And you want to know the best part about integrals? You can always double check your answer very quickly. You just take the derivative. Taking the derivative is always much, much easier than finding the integral. So that was our answer. Now we can double check by simply finding the derivative of this function that we have. What's the derivative of this?
It's 5u to the power 4,
Yeah,
and then 9u squared.
that's it. And notice how this is the exact same thing as this. And you're good to go.
Mm-hmm.
So you can always double check your answer, especially for complicated looking um, integrals. We can just do it right here on the page. So again, this is going to become 35. The 35, you can even pull it out. So this becomes 35 times x to the power 7, okay? Or maybe this will be easier actually, because this 7 is a multiple of 35. So x6 becomes x7, right? The integral, the power always goes up by 1. What do we need to multiply this by to get a 35?
5.
5 plus c, done. Let's move on to this one. You can rewrite that as 63 t negative 8 d8. So is that negative 8 going to become negative 7 or negative 9?
Negative 7.
Okay, so what do we multiply that negative 7 by to get 63?
Negative 9.
9, exactly. And then there's a plus c. Done, easy peasy. Or this one, x 2 over 3. What's 2 over 3 plus 1? It's 5 over 3. So this is going to become 5 over 3, okay?
Mm-hmm.
That thing is going to come down. Remember, that thing is going to come down when you take the derivative. What do we multiply this by to get a 15?
Just with 3.
3 is perfect. Is it? No, 9.
No.
9, 9. 9 would be perfect, right?
Mm-hmm.
Because this goes into this thrice and 15. There you go. So it's going to be 9x power that plus 5. Same thing here. This is going to become power 4 or power 6?
Power 4.
Power 4 is correct. What do we need to multiply that by? That's going to come down, so you'll get negative 4. We need to multiply this by something to get 48. What is that number?
Negative 12.
Negative 12 is correct as well. Is this making sense to you?
Yeah,
Is this difficult?
not really.
It's just the opposite of derivative. That's the best part. Um, it does get harder though. Okay, let's try this one. Okay. If you write this in terms of x, what's the power right now? We haven't done anything to it.
1/2.
1 over 2 or
Negative 1/2.
negative 1 over 2 is right. Now we're going to add 1 to it. So this becomes 1 over 2. So when you take the derivative, you would have gotten 1 over 2x to the negative 1 over 2. But notice how there's no 1 over 2 here. So, sorry, there's no 1 over 2 up here. So what must we multiply this by to get rid of this 1 over 2?
2/1.
2 over 1 or just 2 plus c, and that's going to be the final answer. What's the integral of 4? The number 4.
It's 4x.
4x plus c, done. Most of these are the same, you'll see. It's a complicated looking one. These are all very common, to be honest. We will see complicated ones, but it's not going to be polynomials because they're all very easy, because you can easily check by finding the derivative. Okay, x squared becomes x3, but notice how there's, what do we multiply or divide this by?
By 3.
By 3, divided by 3, right? Because you need to kill the 3. Minus, this becomes 3x squared, or just x squared maybe. There's a 3 here, right? When you take the derivative, the 2 would come down. So what do we multiply this by? So 2 would come down. What do we multiply this 2 by? So I'm left with 3 at the end. You can also think about it that way. Two x equals 3. What's x?
It's 1.5.
1.5 or 3 over 2. Plus 4, well, that's going to be 4x plus c, done. These guys, remember, u to the power of negative 1. Negative 1 is a special case where the integral is ln. You can write it as this, and you can split it apart, which is what we did here as well. These would be the steps. All right, what's the integral of u to the negative 2?
It's u to the negative 1.
Okay. When you would take the derivative of this, you'd get negative 1. But here we only have a 1. So what did we multiply this by?
Negative 1.
Negative 1. So you have negative 1 u to the negative 1 minus, what's the integral of u to the negative 1? Remember, that's a special case. If you add a 1, you'll get
ln of x.
ln of x. Ln of x. The integral of 1 over u is ln of x. So this is 1 over u. The integral is ln x plus c, done. Okay, let's look at 11. So this x3 over 2, what's the power here? No? What's 3 over 2 plus 1? So 3 over 2 plus 1, that's 3
5
over
over 2.
2, 5 over 2. So when you would take the derivative, you would get 5 over 2, but there's no 5 over 2 here. Instead, you have a 10. So what must you multiply this by to get a 10? 4. Okay, 4. Because 2 goes into 4 twice, right? So there must be a 4 here. Plus x1 over 2, it's going to become x3 over 2. When you take the derivative of this, you'll get 3 over 2. But we don't have 3 over 2 there. We have a 6. What do we multiply 3 over 2 by to get a 6? 4 as well, okay?
Mm-hmm.
See if you're confused about this, just turn it into a linear equation. 3 over 2x equals 6, 3x equals 12, x equals 4. So we must have multiplied this by 4 as well. And then there's always the plus c element because it's an indefinite integral. 12. All of these are the same. Once you see the pattern, it's very simple. As is t to the that one's going to be positive 1 over 2. Plus this one will be negative 1 over 2. So this positive 1 over 2, when you add 1 to it, you would get 3 over 2. So when you take the derivative, you would get 3 over 2 times something. You can call it x. So 3 over 2x. We're going to multiply this by something, which is x. And that'll be equals to the coefficient here, which is a 1. What's x? If 3 over 2x is 1, what's x?
It's 2/3.
2 over 3. Same thing here. When you add a 1 to negative 1 over 2, you would get positive 1 over 2. But if you were to take the derivative of that, you would get 1 over 2 in the front. So we must have multiplied this by something to get a 1. And 1 over 2 times x is a 1. That's going to be 2. And you're done with this question. Is this making sense?
Mm-hmm.
Now the book is going to throw at us definite integrals. Remember, with definite integrals, they will give you an upper bound, lower bound. You don't have to add a plus c, but you do have to plug the values in and get a final answer at the end. What's the integral of 9x squared?
It's 3x cubed.
3x cubed is right. Now, once you find the integral, open a line, put your lower bound here, upper bound here, like that. Then you're going to plug the upper bound first, so it'll be 3 times 2 cubed minus lower bound into there as x, 3 times 1 cubed. So this will be 3 times 8 minus 3. So the answer is 21, and you're done. Cool?
Mm-hmm.
I mean, the definite integrals, you just have one extra step compared to indefinite integrals, which is at the very end, you just plug the values in. The idea is the same. Why don't you try this one? What's the integral? Give me the integral function.
Is it negative x to the power of -1?
Yes. So now this becomes negative 12 to the power -1, right?
Mm-hmm.
Minus, and again, whenever there's a minus, it's a good practice to open a bracket, negative 4 to the power -1, like that. So this is negative 1 over 12. This negative and this negative becomes a plus 1 over 4. Take the LCD, so times 3 times 3. So then you'll have negative 1 plus 3 over 12, 2 over 12. So the final answer is 1 over 6. So that's the area under the curve. 1 over x squared looks something like this. So if you were to take the from 4 to 12, what we just found is this area right here. That area is going to be 1 over 6. The y value here is like 0.1 or something. It's very small. Let's just do some of these because the idea is the same, right? It's not that different from the indefinite integrals that we did. All right, what's the integral of dx over x? Which is equivalent to, by the way, this is equivalent to saying 1 over x times dx. What's the integral of 1 over x?
It's ln of x.
It's ln of x. So it'll be ln of x, and then you have e and 1. Plug the e in there. So it'll be ln of e minus ln of 1. Remember, ln and e are inverse functions, okay?
Mm-hmm.
Ln of e, what does that actually mean? Ln of e. This is the ln function. Ln of x. This is the ln function x. Ln of e is this point right here. What's the y value at that point?
0.
0. Wait a second, is that right? Ln of e, they're inverse functions. No, that's actually incorrect. This is not e. E is somewhere here. E is somewhere here. That is 1. Both ln functions are log functions, the parent functions anyways. They always cross the x-axis. Okay, let me prove it to you. E to the x looks like this, right? So
Mm-hmm.
notice how it crosses the y-axis at 1. That means the ln function, which is the inverse, must cross the x-axis at 1. So this x value here is 1. So ln of 1, what would be ln of 1? What's the y value when the x value is 1? 0. Okay?
Mm-hmm.
Ln of 1 is 0. Ln of e is always going to be 1, like that. So ln of e is a 1. Just think about the fact that these are inverse functions. When you multiply one inverse into the other, they cancel each other out, but there's still a 1. F of f inverse of x, whatever the x value is, always going to be x. So here there's no x value. We can say it's 1. So ln of e is a 1. Same idea as this one. Log of 10, right? The base here is 10, yeah? Log of 10 is going to be 1. Whereas log of 1 is going to be 0. What is log base 2 of 2 going to be equal to? Looks like this. Log function, ln functions is always the same. This is an x value of 1. This is an x value of 2. Ln base 2, this is the function ln base 2 of x. When the x value is 2, because these are inverse functions, okay?
Mm-hmm.
Log base 2 and 2 power x, they're inverse functions, it's going to be 1. So the same concept here. So ln of e is a 1, ln of 1 is a 0. You can always plug them in a calculator as well. The final answer is going to be 1. So what we just found, so all this mumbo jumbo, what did we actually just find? We found for the function 1 over x, remember what 1 over x looks like? Looks like this. Doesn't actually cross the x-axis. Looks like that. From the x value of 1 to the x value of e, right here, this area is exactly 1. That is what we just found. And that's the application of integrals. Usually to find areas, obviously it gets way more complicated, as we will see later. Okay, are you ready for trig? Maybe we'll just do sine, cosine. Um, let's see how this goes actually. Let's plot this chart out here. Let's do an example problem. What is the integral of cosine? It's the answer is right there on the right. Integral of cosine.
It's sine.
Sine. So you get sine theta, okay? The d theta and the integral signs, once you take the integral, they disappear. And then you would put 0 here, the lower bound, and you'd put the upper bound here. Are we in degrees or radians? The clue is here.
Radians.
Radians. Sine looks like this. Goes through the origin, 0, 0. And at 90, when the x value is 90, it reaches its maximum value of 1. So what's sine of 90? Look at the sketch right here. When the x value is 90 for sine x, it reaches its maximum value of 1. So what's sine of 90? Or sine of pi over 2? Pi over 2 is equivalent to 90 in degrees. That would be 1, okay?
Mm-hmm.
It's sometimes it's helpful to kind of like remember what sine and cosine look like. So sine, I'm gonna start from the origin. Goes up, comes back down. So this is the maximum value. It's at 1. And that happens at pi over 2, which is equivalent to 90 degrees. Comes down on the x-axis here. This happens at pi, which is 180 degrees. And comes back down to its minimum value. It's always in increments of 90 degrees. So it's 270. In radians, it's 3 pi over 2. Comes to the minimum value of -1 and then goes here. This is at 2 pi where the angle is 360 degrees. And remember, it's periodic, okay? That's the best part. It's periodic. That means this same loop is going to happen over and over and over again. Here's a question for you. Given the fact that sine of x is periodic, what is sine of 450 degrees equal to? There's three options. It's either 1, 0, or -1. Those are the three options.
It's 1.
It's 1. What sine of 720 equals to?
It's
It's 0. Because 720 means 3, so you see this 360?
mm-hmm.
720 is another full loop. If you add 360 to this, you would get 720. So you would get right back where you started. Okay?
Mm-hmm.
Sine 450 was a 1 because here you add 90 degrees to it, which means you take this little chunk and you move it over there. It's periodic, so it's going to repeat. It's going to be 1. Same thing. 360 means it's 2 loops. So you'd end up right here where the x value is 0. So sine of 90 is a 1. Sine of 0 is a 0. So that area is going to be 1. They didn't give us much examples here, did they? They're throwing out a straight out. All right. Trig is always annoying because you need to know the background info, which we have covered for the most part, like sine and cosine. We've talked about it many times. Tan is just a combination of sine and cosine. So if you know sine and cosine, you can get tan very easily. I'll show it to you here. So we're going to cheat a little bit. What's the integral of tan? It's on the right side. Remember, the derivative is sec squared. What's the integral? It is ln, okay, of sec theta. Do you agree?
Mm-hmm.
And then here our angles are 0 and pi over 3. There's no plus c here because this is a definite integral. Now, we need to evaluate sec of pi over 3 and sec of 0 to give this question a numerical final answer. You can always plug these in a calculator, but if I was a teacher, I would give this question on a non-calculator test. So now the question is, how do we find these without the use of a calculator? You need to know that sec is the reciprocal of which primary trig ratio? Sine, cosine are 10. If you flip one of them, okay, you'll get,
Sine.
so it sounds like it's sine, but it's not. Secant sec is the reciprocal of cosine, okay? CSC
Mm-hmm.
cosecant is 1 over sine. Sec is 1 over cos, and cotangent, it's in the name, cot is 1 over tan. So to find sec, find cosine and just flip it upside down. Here's what you need to find cosine of pi over 3. It's called special triangle. This one is the 30-60 special triangle. 30 means pi over 6 in radians. 60 means pi over 3 in radians. And the dimensions of this triangle is 1, 2, root 3. So if I asked you, what is cosine of pi over 3? Remember, cosine is adjacent over the hypotenuse. What would you say?
It's 1/2.
It's 1 over 2. So what is sec of pi over 3? Remember, secant is just cosine flipped upside down. If cosine is 1 over 2, secant would be 2 over 1, okay?
Mm-hmm.
It's just it flips upside down. So here, ln of secant pi over 3, that's the absolute value symbol, minus ln, and there's an absolute value because ln cannot take negative numbers. If you remember the ln looks like this, it'll never take any negative x values. There's an asymptote right here on the y-axis. Minus ln of secant of 0. So secant of pi over 3 is 1 over 2. So you have ln of 1 over 2 minus ln of, now what is secant of 0? The special triangle is not going to help you find that. What will help you find this? Eventually you're going to memorize all of these. The cosine curve. The cosine curve looks like this. This value, the initial value, is 0, 1. So what is cosine of 0? This is the cosine curve. What's the y value when the x value is 0?
It's 1.
It's 1. So if cosine of 0 is a 1, remember secant is just cosine flipped upside down. What's sec? Right?
Mm-hmm.
So you get ln of 1. Ln of 1 is special because remember, ln always goes through ln or log, in fact. Ln functions and log functions always go through the x value of 1. So when the x value is 1, what's the y value?
0.
0. So this entire thing is a 0. The final answer here is ln of 1 over 2. Cool?
Mm-hmm.
Let's see if we can do a little bit more complicated one. Shouldn't take us too long. Let's do this one. What's the integral of theta? It's the same thing as x. You can treat theta as an x. What's the integral of x?
It's 1.
So if you have this, right, it'll be x squared over 2. Same thing here. What's the integral of theta then? It's just a different letter, right? The idea is the same. This
So
has a
theta
power.
squared over
Yeah,
2.
yeah. And the
Okay.
integral of cosine is sine. Cool, like this?
Mm-hmm.
And then you have 0, pi over 3, and then you just plug the numbers in. Pi over 3 squared over 2 plus sine of pi over 3. This is going to be root 3 over 2 from that triangle. If you check that triangle opposite over adjacent, you get root 3 over 2 minus, now you plug 0 in there, 0 squared over 2 plus sine of 0. Sine of 0, we did it somewhere here. It's a 0. So this is a 0, 0 squared over 2 is a 0. So this entire thing essentially just disappears. So the final answer here would be pi squared over 9 times 2, 18, plus root 3 over 2. Final answer, and you're done. Cool?
Mm-hmm.
It's not terribly difficult. Don't worry about these. It just looks complicated. You're just plugging things in, and as long as you have the special triangles, you can find every single one of them because sine, cosine. Once you have sine and cosine, you have everything. You have tan, you have all the reciprocals as well. All right, let's call it there for today.
Okay, thank you.
Yeah.